Thank you for joining us for today's webinar. My name is Marcus Brower. I am the Executive Director at the University of Wisconsin-Madison's Institute for Diversity Science. The Institute supports and promotes data-driven research on questions related to diversity, equity, and inclusion. We have 50 affiliate members, affiliate faculty, and all of them in all schools and colleges of the University of Wisconsin-Madison, and all of them share a common interest. They share interest in data-driven empirical research related to diversity, equity, and inclusion. Welcome today. If you have a chance, feel free to put where you are from in the chat. It's always interesting to see that we have audience members from all over the country. Today is about artificial intelligence. We're going to talk about the intersection of bias, equity, and artificial intelligence. And issues around AI are complex and they're rapidly shifting. And we put together a panel of nationally renowned experts to understand some of the ways artificial intelligence impacts issues related to DEI, diversity, equity, and inclusion. I'm honored to introduce the guest speakers for this webinar, Kalinda Ukanwa, who is assistant professor at the University of California, Irvine, where she is at the Mirage School of Business. The second speaker is Corey Jackson, assistant professor in the information school here at the University of Wisconsin-Madison, and he is an Institute for Diversity Science affiliate. The third speaker is Shamya Karumbaiah, who is assistant professor at the, again here at University of Wisconsin-Madison, Department of Educational Psychology, and also affiliate member of the Institute for Diversity Science. Let me tell you what's going to happen today. In just a moment, I'll ask Kalinda, Corey, and Shamya to tell us more about themselves, short introductions to who they are. Then we're going to have presentations from each of them, about 8 minutes each, where they will share their thoughts and their insights on AI and bias. After that, I will ask questions. I have some follow-up questions for our speakers. And then finally, we're going to open it up for questions, Q&A from the audience. So this is the moment where I'm going to suggest to you that you type questions or comments in the chat. And then I will address these and ask the speakers to react to them. Okay. Some technical logistic issues. We have captions enabled today, and we hope that those are helpful for you. This webinar is recorded, and we will send you a copy of the recording as soon as we can, hopefully by the end of the day tomorrow. Wonderful. Then I'm going to go ahead and ask each of our guest speakers to briefly introduce themselves. Let's start out with Kalinda. Kalinda.
Thank you for that introduction, Marcus. My name again is Kalinda Ukanwa. I'm an assistant professor at, as of last month, at University of California at Irvine, Paul Mirage School of Business. Prior to getting into academia, I worked for companies for 15 years in quantitative roles in finance or analytics, and I continue that theme with my research. I am a quantitative modeler, and the areas I study are marketplace disparities and the impact on firms and consumers. I specifically am an expert in artificial intelligence and responsible AI, with a lot of my research about algorithmic bias and algorithmic fairness.
Thank you so much. Corey Jackson.
Hi, thanks, Marcus. So again, my name is Corey Jackson. I'm an assistant professor in the information school. I've been here about starting my 4th year. I graduated from Syracuse University with a PhD in information science and tech. I've kind of always been fascinated by how people leverage technology and information to organize, collaborate, and communicate. And so that fascination has kind of driven a lot of my research, particularly in understanding how technology can empower communities, facilitate collaboration, and really drive social change. And so the ability of these different technologies to bring diverse voices into really important conversations and decision-making processes has always really been fascinating to me. And so the question of like, how can we harness collective intelligence of publics to solve societal challenges is really central to a lot of the work that I do. And so kind of with that foundation and kind of some of the work that I've done previously on citizen science, really the connection to AI and ML here is centered on involving crowds in public sector AI and getting crowds to provide meaningful insights into how we can build more responsible artificial intelligence. And so happy to kind of share some of my initial thoughts about that work later on.
Wonderful. Thank you. Shamya.
Hi, thanks, Marcus, for that introduction. I'm very happy to be here. I'm an assistant professor in the Department of Educational Psychology here at University of Wisconsin-Madison. I conduct research in the intersection of machine learning and learning sciences. And I came to this work as a computer scientist, super interested in building predictive models of educational constructs, such as student cognition, affect, and motivation. And in my doctoral studies in learning sciences, I was introduced to this inextricable link between learner context and their learning. And hence, in my dissertation, I started exploring how ignoring learner context may introduce harmful biases in these predictive models. And I've continued that line of research as an assistant professor here, where I'm currently focusing on developing equitable and responsible use of AI in classrooms. And particularly in the last couple of years, my lab has explored potential issues of biases, particularly linguistic injustices that the large language models are perpetuating, which I'm very happy to be presenting later on today.
Wonderful. Thank you. What the three speakers did not mention is that they're all highly accomplished, highly qualified, highly productive scientists who do cutting-edge research on questions related to AI and diversity, equity, and inclusion. I'm incredibly grateful that you are here today. Okay, now let's start the core part of this webinar, which is presentations by our guest speakers, and we're going to proceed in the same order. Kalinda, I'm going to call on you, and I think you have some slides that you want to share with us.
Absolutely. So I'm going to go ahead and share those slides. Hold on a second. All right. Hopefully everybody can see. Can you give me a thumbs up if you?
Yes. Yes.
Okay, great. Fantastic. All right. Well, again, thank you for joining us today. Really appreciative. I want to thank, for example, first of all, the Institute for Diversity Science. Thank you for inviting me to be a part of this webinar. I'm happy to share some of the research that I'm doing, which is very much from the point of view of firms as well as consumers, and every single one of us on this webinar is a consumer and a citizen of this world. So I'm going to tell you a little bit today about responsible artificial intelligence, fair algorithms for a fair society. Those of you who are not familiar with the term responsible AI, what is it? It's basically an approach, a set of principles around how to build, design, develop, manage artificial intelligence in a way that can extract all the benefits that it can provide without while minimizing the harms. These are the general areas that are focused in responsible AI. Responsible AI is basically where my expertise lies. I want to show, even though there's these 5 areas, most of my research is really focused on this first here, where you see fairness and equity, which is how do we develop, deploy, and design algorithms and AI in a way where it is as fair as possible to its constituents. And so what do I mean by constituents? Stakeholders includes firms, consumers, every one of us are consumers. Many of us work for firms or are part of firms. And then government and policymakers, they all have a stake in this and all have a deep sense of responsibility in terms of creating responsible AI. And with that, I include data analytics. The two are not really separate, but a continuum of the whole process. And that last part about legislative and policymakers, where we are now is this is an active moving area that changes literally by the day. There is not extensive legislation around the world around this yet, although the EU, which I see as a leader, just recently adopted an overarching set of regulations around artificial intelligence this year. The US is a little bit behind. We have a bill that's out there, but that has not been passed. It's been reintroduced 3 times, the Algorithmic Accountability Act. Hopefully there'll be some movement, but they all in general, I mean, and of course there's individual actors, other countries, individual actors within the US in terms of states, but all seek to have this sense of collaborative governance that involves firms being asked to use and develop algorithms and AI that are generally fair and responsible in terms of society, asking us as consumers to let firms know when they're not, and asking policymakers to help regulate it so that it balances concerns of both firms and consumers. But there are a lot of questions that arise around this, and this is kind of the heart of a lot of my research in terms of how do we collaboratively work on these things if, for example, consumers don't have access to data or the inner workings of an algorithm, if firms and consumers don't necessarily have the same definition of what fairness is, if policymakers don't have insight in order to balance these two things. These are some of the questions I'd like to explore. And in terms of my research, I've developed a framework around the whole process. If you think of developing the production of AI, there really are 3 major steps in its production. There's the design of the AI, the development of the AI, and then the deployment of the AI, and hence my framework, which is called the 3D Dependable AI Framework, which I won't have too much time to go into, but feel free to ask me or contact me later with questions. But I do have an article that just got published in the Current Opinion in Psychology that goes a little bit more into it, is a framework that is developed about how do we as a society, how we as a stakeholder, whether we're a firm, consumer, or policymaker, should think through these things in terms of seeking to develop consistently artificial intelligence that is dependable for us and responsible. Why is this important? There's so many concerns about this. Algorithmic bias, which is defined as systematic errors from the algorithm that create unfair outcomes for certain demographic groups. It's correlated with that. Shows up in many ways. And then these are some of the headlines in recent years that make it realistic how this happens, whether it's from Apple Card to how algorithms grade school exams to facial recognition AI that mistakenly accuses, in this case, this man of committing a robbery. These are all important to all of us. And one thing that I like to tell people is that, so often this is it's politicized, but it shouldn't be a political thing. An analogy I like to think of is the automobile. When it was first introduced, it was this great technology that actually allowed us to go farther, faster than ever before. It transformed society. But at the time that it was created, people weren't necessarily thinking of safety, in terms of stoplights, rules about driving on the road, safety belts. These are things that made driving and the new technology of the automobile safer, while yet allowing us to extract all its benefits. Analogously, the responsible AI and seeking, for example, algorithm fairness is seeking to do the same thing, where it's not a political concern, it's a human concern that benefits us all. How do we make this safer so that we can get all the benefits that we can get without having headlines like these become commonplace? So some of the research that I'm doing to explore this includes whether under what conditions is algorithmic bias bad and good for business. I try to look at it dispassionately. How can algorithmic bias impact consumer choice, consumer preferences? And I have a paper that shows that it can silently impact my choice, your choice, everybody's choices without us even being aware that the bias exists in the algorithms. How does it trigger unfairness beliefs? I have another paper where under certain conditions, even if the algorithm is deemed fair by the firm, it can still trigger unfairness beliefs. And under what conditions can that be, especially if we as individuals judge fairness differently from how a firm might? And then I have another paper that shows under what conditions is it profitable, where I show algorithm bias can actually be profitable for firms in the short run, but over time can become unprofitable. And so I show conditions under which over the long run, it's no longer profitable. And so with that, I want to stop here. I mean, and that just gives you a bit of an overview of the kind of research that I do, which is, again, looking at algorithm fairness and bias, and then under what conditions, and how does it impact firms, consumers, and policymakers in its use and deployment. Thank you.
Thank you, Kalinda. This was amazing. I immediately have about 10 questions, but we have to hold off with questions. We want to give the other two guest speakers a chance to present their slides. Immediately, a message for the audience. If there are questions that you have or concerns that you want to raise later during the Q&A, please start thinking about it, and then I will ask you to type them into the chat. Next speaker is Corey. Corey, the stage is yours.
Thanks, Marcus. So I'm going to take a little bit of a different perspective than Kalinda and talk about a project that I am planning to do. And so again, one of the main questions that kind of guides a lot of how I see the world and solve problems is really focusing on how can we harness the collective intelligence of publics to kind of solve societal challenges. And the idea is that knowledge isn't just held by experts, but it's kind of distributed across populations, and we can leverage that knowledge to, in this case, build better tools and systems or applications for AI. And so that's kind of where a lot of my work is centered on, is building and assessing tools. And so I think there's a really unique opportunity in public sector AI. So around the world, governments are adopting AI to leverage benefits like optimization of processes, predicting trends, and automating tasks. These are just a few of the headlines that I've come across in the last week. So the Department of Energy is using AI to speed up permitting. OpenAI has a new partner with USAID, and of course, there are other applications for AI in government as well. In the federal government, so there's a lot of different use cases, and recently the Biden, well, maybe a year ago, the Biden administration put out a request that all departments make public their use of AI. And so if you want to see how different departments are using AI, all of that information is public now. But we see that there's a lot of different use cases: social media surveillance, predictive policing, automated decisions for immigration. There are a lot of different use cases for AI that touch humans. And I think that's really important to really reflect on, that there's a lot of decisions being made in sort of this black box of AI. And so we're starting to see some movement, at least at the federal level, around guidance for making these tools public, making public the data sets that they use, and who they're owned by, and whether they can actually be audited. But the situation becomes particularly complex at lower levels of government. So here, these systems are often implemented with less visibility and oversight. And in many cases, their applications and impacts are lesser known to the public. And the use of these tools in sort of smaller municipal governments is expected to grow. So the stat from Bloomberg Philanthropies, 58% of cities are exploring generative AI's potential applications for data analysis, and 76% for policy making. And so I think within the next couple of years, we can expect to see an increasing use of AI. But we know that there are harms when AI is used. And so these implementations can offer benefits to local governments, but like other implementations of AI, they can also raise concerns. So one use case here is Thomson Reuters has a fraud detection tool that looks to social media information, credit reports, housing reports to predict if public benefit applications are fraudulent. And so the tool also uses things like social media profiles. And so in a Freedom of Information Request Act, FOIA request, they found that California implemented this algorithm, and it inappropriately flagged, I think, around 1 million unemployment insurance claims as suspicious. After some analysis, they found that only that about 10% of those were categorized incorrectly. And so there is potential harm, real harm, that these algorithms can cause when they're not scrutinized properly. And so these harms have real impact on people's livelihoods. So access discrepancies, as in the case of a fraudster, can prevent people from actually getting benefits that they need to survive. The opacity of these systems also means that there's a lack of accountability and possibly a loss of trust in government if people can't sort of challenge how these tools make decisions. But there's also, and where I think is a real opportunity, is a lack of ability to incorporate needs and values of communities in public sector AI. And so sort of this question here, how might we incorporate expert knowledge in public sector AI to reduce the potential for harms, is really sort of important and has been on my mind for a while. And so I kind of want to present what I think are some useful approaches to mitigating those harms for the future in public sector AI. And much of that centers around these participatory approaches to AI, which essentially involves diverse groups of people in the design and development of these systems. And so this approach means that we're developing systems that go beyond sort of the traditional expert-driven models and incorporates knowledge, values, and experiences of diverse communities. And the idea is that these can help create more democratic and inclusive governance processes, which leads to greater trust and acceptance of these tools. So how might we incorporate this expert knowledge? Well, we know that understanding values is really important. So how people think about the choices for when they build models might be important to kind of think about, and is an area where I think publics have a particularly unique set of expertise or skills in really thinking about homing in some of the choices that developers need to make as they're building these models. And so there's a ton of questions around value alignment. So how do I identify and prioritize values? And how do we make sure that these values remain adaptable and responsive to evolving societal needs over time? And so when we're thinking about building these tools, increasing sort of who we consider as experts, I think, is really important. And so moving beyond sort of just the developers of the tools, and maybe in the case of public sector AI, just public administrators, but really thinking about ways of involving publics in sort of scrutinizing these tools. And so my team has been doing a bit of work on mapping out some of the spaces or places where we think publics might contribute to scrutinizing these models in this development lifecycle. And so this question of how can publics contribute expertise in the development and oversight of public sector AI is kind of central to some of that work, although we can look at other stakeholders and think about ways that they might contribute as well. And so publics might be able to provide insights around cultural norms, social values, and community-specific issues. Other groups, like non-governmental groups, might be able to provide practical, on-the-ground insights. But overall, having a wide range of perspectives helps ensure that some of the most marginalized might be included in that scrutiny of those systems. And so I briefly want to talk about one example use case in auditing public sector AI. And so this is a project that we've sort of brainstormed over the summer and we'll be working on in the fall semester. So one of the ideas that my team has been working on is adding audits to supplement the AI development process. These audits would involve community members early in the design phase to identify biases, ethical concerns, and real-world impacts before the systems are actually deployed. And auditing is actually used towards the end of this development lifecycle as well. So the idea is that we're putting a pre-audit to incorporate some expert knowledge from community members. So the way that this would work is that ML developers would present an ML problem, trained publics would audit the machine learning, and then the crowd audit is supplied to developers who make adjustments to the model based on the needs and preferences of the community. And so what that might look like, so on the top slide, we can see an example scenario where developers might present to the public. In this case, the scenario involves modeling for vaccine allocation during a public health crisis. The model's goal is to prioritize delivery based on factors like age, health conditions, occupation, and geographic location. On the bottom half of the slide, there's an example of how publics are involved in that audit process. So after reviewing the scenario, community members might be asked to provide feedback by answering a series of targeted questions designed to capture community knowledge and identify factors that the model might not be considering, for example. And so the outcome of that crowd source audit process might be these audit summaries where we have information about the auditor group, so who's being represented in terms of things like age, gender, race, and ethnicity, aggregated responses to some of the auditing questions. The idea is that these can be tailored to specific contexts in which the developer is working in, and then recommendations for developers based on the evaluations that the community made of these systems. And so in this sort of process of incorporating expert knowledge, we kind of see taking these pre-audits and actually involving them in part of the AI or ML developers process where they're actually building the model. So they might take some of that expert knowledge and again, make tweaks to some of those systems. So it's important to not acknowledge that, and so that's just one example of how we might sort of further democratize AI in the public sector. But it's important to acknowledge that participatory AI, especially in the public sector, presents opportunities and challenges. Each stakeholder group brings unique expertise, but they also face challenges that kind of limit their capacity to be involved as partners. And so using some of what I've learned sort of studying citizen science projects where non-experts are able to do pretty amazing things, over the next semester, we'll be researching ways of increasing capacity for publics to be involved in things like audits. And so developing sort of these strategies for involving folks is going to kind of be the focus moving forward. So I'll stop here. Thanks. Always interested in collaborators, so feel free to reach out if any of this work sounds interesting. Thanks.
It sounds very interesting. Thank you, Corey. I'm sure we'll have questions later. Shamya, are you ready to take over? And you have a special setup where we not only can see you, but you only have what, a different screen where you can write things on or circle things. We're all curious to see how AI works. Just take it away.
I know I'm from education, so I certainly have to go to a whiteboard, and I'm a computer scientist, so I'm going to open up the models for you. So, hi everyone, I'm Shamya again. Today I'll be talking about work that I've been doing on characterizing language model biases using students' linguistic variations. So we will be looking at predictive models. So just to get everybody on the same page with what predictive models are these models where you give it student data and it gives you back some predictions. So it could be essay data, which is goes to maybe like an assessment model, and it tells you whether there is a certain kinds of ideas or potential misconceptions in students' understanding. The way usually we measure model performance is we compare the predictions that we get from the model to a set of human annotations. So for all these essays, we are going to look at what the machine said as the idea and what the humans are saying as the idea. And we compare the accuracy between the humans and the machine to see how well the model is doing. And that is the idea of model performance. I'm trying to move my screen. Okay, there you go. So coming back to this idea of algorithmic bias here then means that when we take these model predictions and we are looking at accuracies, we are going to compare the different demographics. So we're going to look at how the model predictions are going to look different based on whether they are from a particular gender or a particular race and so on. So bias is often defined then as a difference between accuracy of a group A and accuracy in group B, maybe, right? The limitations here are several. So certainly that in my field of education, it's hard to collect student demographic data for issues of privacy. Often these demographic categories themselves tend to be oversimplified and politically influenced categorization. They almost always also assume homogeneity by nature of it, whereas groups are usually heterogeneous and may have intergroup similarities. And there's also the issue of intersectionality, where it's not just the race, but also a combination of race and gender. So that's about limitations of the way algorithmic bias research works more broadly, but there is more when it comes to large language models. Large language models are these generative AI models that predicts the next token given a set of tokens, right? So the prediction model then gets reframed as fill in the blanks kind of a format where you're prompting the large language model to give you the prediction. So energy can't be created or destroyed. This explanation is dash, and something like ChatGPT would tell you whether it's correct or incorrect, and now you have prediction. But the big difference, my pointer is not working, unfortunately, but if you can look at the last set of comments I have there, one of the predominant ways in which it is different from traditional way of doing predictive modeling is that you don't usually have human annotations, but not in large amounts of it. You also are not doing explicit training for a particular use case. While it opens up new opportunities, it also poses challenges because now you're not doing a rigorous evaluation, which becomes important for high-stakes settings like education. So going back to the limitations of current approaches of algorithmic bias research, a new added issue is that we don't have human annotations. And if you don't have human annotations, how are we going to compare accuracies across different groups? Okay, so this is where we are in my lab coming up with a new approach with these constraints in mind, that we don't have annotated data, we don't have student level population definition. And the new conceptualization is LLM bias as a consequence of linguistic variations in students' writing. So let's take an example of a student response like energy cannot be created. And if we introduce a variation, for instance, language variation, so Spanish translation, if the assessment changes from correct to incorrect, that's a measure of bias, because these variations are expected to be something that the model output needs to be invariant to these variations. Okay, because the idea is the same, only the language has changed, so the assessment should not change. Okay. Just a little bit more about linguistic variations. This is not a new idea. We have seen that in natural language processing as perturbations, potentially. Also in measurement equity as nuisance dimensions, although I don't like the phrasing of it, but yes, nuisance dimension. In nutshell, linguistic variations are construct irrelevant, meaning the construct should not change to these variations, and hence the prediction of an LLM should not also be changing. So hence auditing for LLM bias will then become testing invariance to these linguistic variations. So this is a way in which we open up the opaque large language models that don't have features that we can interpret to potential causal analysis of bias. Introducing linguistic variation, does it lead to potential differences in LLM prediction? Here are some examples of variations. I'm happy to come back to this later if you want to take a look at it. But in terms of the theoretical framing, where I'm coming from is also in it's very much embedded in education, which is that of translanguaging. So this is a theoretical framework for bi-multilingual education, which looks at student populations as multilingual student populations as a heterogeneous group with different kinds of linguistic practices. And it often defies boundaries between named languages. Those of you in the audience who are multilingual people, think about conversing with your sibling with maybe two languages that both of you speak, of course. And then you will see how in a single sentence, you are just switching between languages very, very fluently. So translanguaging has basically tried to see how can we bring this to a classroom, to science learning. And the fundamental idea or a stance on language here is that language boundaries are created socially and politically and not lexically and structurally. We can debate about it in Q&A if you want. But there's enough research showing how translanguaging supports deeper engagement, meta-linguistic awareness, homeschool links, identity development, and so on. Okay, I'm going to quickly present some preliminary results from the work we've been doing. And this is where we look particularly at multilingual large language models. And we explored Llama 3.1, Gemma 3, and Nemo. And despite these models being multilingual, we are already seeing a difference between their performance when we give it student data that's all in English, all in Spanish, or Spanglish. Like you see some of those numbers there. And this was the task of identifying ideas from students' explanations. So what we did for translanguaging training is first we created a synthetic data set, and we used another large language model called Claude. So we asked Claude to generate these synthetic data sets by posing a question, answering itself, like by itself, and then giving an answer that is correct or incorrect. So we get this kind of data set, question, answer, and label. And we then take that and we only translate the answers into Spanglish. So now we have two data sets, one with a set of answers in English, another with Spanglish, both with labels of whether the idea was correct or incorrect. We take this and we fine-tune these three multilingual large language models, and then we evaluate it also on a synthetic data test data. And this is what we are seeing. I wish I had my pointer, which is not working for some reason. But if you look at the gray highlight, that is the difference between baseline. So if you look at the gray boxes, 0.70 and 0.86 is what the baseline model does differently for the Spanglish answers and English answers. Okay, of course, it's a measure of bias then, right? What's interesting is then when we fine-tune this model by giving it English-only data again, the Spanglish data set only improves by 0.05. So the improvement in model prediction only improved by 0.05, that is 0.7533 if you see, compared to 0.933 in English fine-tuning. And the promising result that we have is, instead of English, if you fine-tune the model with Spanglish data that we generated, then you see a lot less bias. So you can compare 0.96 to 0.94 accuracy. So that's a little bit more comparable compared to these other numbers. Anyways, so in a nutshell, we have also planned a few other analysis along these lines. We certainly want to replicate what we found with authentic classroom data and not just synthetic data. We also want to get stakeholder feedback on these linguistic variations, ideally teachers. And we want to curate a list of linguistic variations that we can use for code, that we can probably get from code switching literature. So in conclusion, what we have done in this project is we have conceptualized LLM bias as a consequence of linguistic variations in students' writing. So we have redefined bias not as a difference in accuracy between different groups, but rather between whether you see a particular variation or not in students' writing. And we believe that this allows us to do bias audits and causal analysis with the constraints in mind, which is that with large language models, we don't have annotated data more often than not, and that we don't have student-level population definition. Thank you.
Thank you, Shamya, and thank you, the other two speakers. It's fascinating to hear what are the recent developments in this very large field. Before I go on, I want to remind the webinar participants that in about 5 minutes, 10 minutes, I'm going to open it up for questions, Q&A. So if you have points that you want to raise, please put them in the chat. I also looked in the meantime who we have here. We have people, it's a non-exhaustive list: Pennsylvania, Minnesota, California, Tennessee, Washington, D.C., Kansas, Utah, Virginia, New York, and probably many other states. And one person lives in Pennsylvania, but is currently joining us from India. So this is all fascinating. Thank you for tuning in today. I'm going to limit myself to one question per speaker and then hand it off to the audience. Kalinda, can I start with you? So you told us about your framework, which I thought was absolutely fascinating. You called it the 3D dependable AI framework, and 3D stands for design, develop, and deploy. And if I'm it seems to me that you've published recent work, but done some work recently of how firms, companies can address algorithmic bias with your framework. And could you just tell us more about that, elaborate on that?
Sure. So, thank you for asking. I'm very excited to talk about this. As I mentioned, it was just published this month in Current Opinion of Psychology. But this framework was originally designed candidly around how to think about research and algorithmic bias and areas for opportunities and how social scientists can be engaged in this process. Because so often, a lot of the research that's done in algorithms and algorithmic bias, in particular, algorithmic fairness, is very much in the domain of computer science, but there is much more that needs to be heard from sociologists, psychologists, political scientists, philosophers, people of the humanities and social sciences who have expertise around society, human beings, et cetera, and how that is married up with and engaged. I would even include in that those who are scholars in education. But it also is a framework that can apply to firms because it follows the AI development process. First you design the algorithm or artificial intelligence, and then you need to develop it. That's through training the algorithms, fine tuning parameters and hyperparameters, reworking, and then there's the deployment of it. And putting it out in the world. What you might have designed and developed may not necessarily work in the real world as intended. And so in each one of these phases, bias can be introduced. So this framework is basically a systematic way of really thinking about it as opposed to doing something ad hoc, which is still can be very helpful, but it's not necessarily systematic. So in the design phase, where firms can really engage is really thinking through, instead of taking an algorithm off the shelf or at least, or even development to say, hey, I need to have a better way to scan resumes, or I need to have a better way to decide who's going to get a loan, et cetera. To really think through, is this the right algorithm to use in the first place? Are these the right features of data that we should be using? Or is there bias inherent in the choice of these features? Or is there another way that we can achieve the same goal without thinking about that? And then there's the process of development, which is training of the algorithm with your training data, and fine tuning and reworking that. Are we thinking through in terms of a very systematic way how we are doing this while we're minimizing some of the potential harms, such as bias? Are we making this fair? Are we using the right measures to figure out whether we're there? And then you can do the first two phases perfectly, and then you deploy. Say you have a perfectly designed and developed algorithm to determine who should get into an all-boys school in terms of admissions. It might work for that context, but when you deploy it to a co-ed school that has both boys and girls, maybe suddenly because of the way it was designed and developed and trained, now it can exhibit some biases against girls because it wasn't intended for that use. And so it's a systematic framework to think through in every step of the way, and gives guidance in terms of what are the things you should be thinking about, what are the things you should be looking at, and how do you develop a whole parallel framework analogous to what I had talked about earlier about automobiles that thinks them through as you're developing the newest automobile. Is this safe? Is this designed in a safe way? Is it trained in a safe way? Do we have infrastructure that allows the automobile to be as safe so that we're not killing people on the roadways or going off the cliffs, et cetera? So that's what I have to say. And that's how it can guide firms.
Wonderful, Kalinda. I can't wait to see if companies are going to pick up your framework, and I'm sure they will. Corey, I was intrigued by your crowdsourcing approach. And two thoughts that came to my mind is, how do you ensure that there's equitable, good representation of various social groups in that crowdsourcing approach? And can you sort of imagine certain things where that crowdsourcing approach, AI approach may not work? Or if you want to formulate it positively, are there certain situations or settings where that crowdsourcing approach is probably going to work extremely well?
Yeah, so just taking a step back, a lot of the folks in my field, one of our goals is to kind of design systems or build tools to solve societal challenges. And so this sort of participatory AI framework is one that a lot of folks in our field have built upon. And it's also kind of emerged from this idea of participatory design. So getting a lot of people engaged in the process of building tools. That works well, depending on the technique that you use, that works well for some groups, but not for others. And so in particular, thinking about the involvement of minoritized groups in policy, for example. So I'm working with another collaborator on thinking about ways of involving underrepresented groups in environmental policy. There are special sort of approaches to engaging Black and Brown people in thinking about policy, for example. And so what we've learned was that things like open deliberation is really important. So getting people together in the room to talk about some of the issues that they face, as opposed to just providing feedback on forms, for example. And so one of the ways that I think we can build out diverse opinions in these audits is by incorporating nonprofits who are doing work with underrepresented populations, for example, in whatever domain or with whatever geography you're planning to sort of deploy that public sector AI. And so from my perspective, we've kind of leveraged our work with nonprofits, and I think they really serve as important interlocutors for communicating insights and also enrolling people in sort of providing feedback to some of the topics that we've covered, like environmental policy. In terms of places where this type of tool would work well, I think there's a lot of different use cases for public sector AI, and there's a lot of use cases that we don't necessarily know about. I think where it's most needed is in public sector AI that touches human lives. So, for example, the case of deciding who receives benefits, I think, is an important space for community feedback to be included. So anywhere where algorithms, I think, touch human lives is really, I think, an important point for us to really be thinking about, including communities, but also folks who have subject matter expertise in those audits as well.
Thank you, Corey. I had a question for Shamya, but then somebody posed the question in the chat, and I actually find that question so interesting that I want to retract my question and take the one that's in the chat. Carla is asking a question for Shamya, and she's asking, well, is the issue linguistic variation? Is it the case that bilingual individuals, when they interact with AI, do they use multiple language? And she says, I'm myself a bilingual, and actually when I type something in the chat GPT, it's not that I'm switching back and forth between Spanish and English. But where my bilingualism may come into play is I may type an English sentence, but it may be because I'm typing fast, grammatically incorrect, because I'm using a sentence structure that is more common in Spanish than in English. So is the issue then linguistic variation, people switching back and forth between two languages, or is the issue making grammar mistakes when interacting with AI?
That's a great question. Okay, so let me just clarify my context a little bit more, just to bring it back to the particular research that I'm trying to do. So Carla, I'm thinking more about the interactions that's happening between humans and then AI supporting that, as opposed to a human AI interaction directly. So it's my context that where I conduct research, for instance, is a classroom where it's a bilingual dual immersion program, for instance. So you have a classroom full of students who speak Spanish and English. These could be native speakers of English learning Spanish or native speakers of Spanish learning English. And Madison has one such school here, for instance. And if you go to one of these classes, you will see that there may be a small group discussions happening around different tables across this classroom, where the students are talking with each other in different languages, in whichever language is accessible to them to convey the ideas that they have. So now imagine a talking rock on each of these tables, that is listening to what the students are saying and summarizing their ideas or detecting their ideas to maybe support them in developing an idea map. Or it's bringing those ideas back to the teacher because the teacher cannot be in each of these tables, right? Or another example is all of this is happening in, say, rural Wisconsin, where it's a monolingual teacher maybe who doesn't have access to or who doesn't understand Spanish. So they have no idea what's happening in the small group discussion, right? So that is my context. And with that context in mind, what we are interested in is identifying potential biases that large language models may have, these talking rocks having large language models, right? In identifying those ideas that these students are talking in their natural setting. I'm totally with you. If you had asked me 8 years back when I started my dissertation, I would have said, so I was all into AI tutors. So all my dissertation work was about student AI one-to-one interaction. But as I started to build my programmatic research here in UW-Madison, I focus more on AI as something that is part of a classroom ecosystem where AI supports human interaction and flourishing and everything else around it, as opposed to AI being the center. If that makes sense. So with that in mind, linguistic variations matter because it's now the LLM being able to identify those. Okay, great. Thank you. Thanks, Carla.
Wonderful. I'm looking at the time. We have, Corey, one short question. I think it's going to be super short. One person asking, how long would training public participants take to train them to provide feedback related to AI?
Yeah, it's a good question. And the short answer is we don't know yet. So part of the first step of this audit process is actually taking use cases from the federal government and actually attempting to come up with context descriptions and audit those to see what information people need and how we can translate that information, translate the model descriptions to information that's sort of understandable by people without expertise. We're also looking at ways of developing training materials to teach people about machine learning. And again, I think these are all sort of open questions for us that we are interested in investigating for the next semester.
Wonderful. Well, time's nearly up. I want to give each of the speakers one more chance to sort of formulate a key idea or a certain take-home message that people should walk away with from this seminar. What do you think is crucial? What's the future? What are you preoccupied about, and what should we really be thinking about? What's next? Kalinda.
Well, if there's one takeaway I hope people walk away with is that that questions around inclusiveness, around fairness and bias around artificial intelligence. I hope everybody sees this as a human problem, not a marginalized people's problem or a female problem, but that it's really a human problem that should engage all of us. And it's not, I don't see it as something that it's often politicized, but it really puzzles me about why it's politicized. I'm going to use the analogy I've been using throughout, which is, again, think about the automobile and then safety for all of us. Where's the politics in that? And so if we can apply the same kind of thinking to this, and that we want this technology that is rapidly developing very, very fast. We want to be able to put some guardrails around it so that it is also safe and fair for all of us. And so I hope that everybody walks away with that particular thought. Let's think through how we have driving rules, stoplights, safety belts when it comes to AI.
I agree. Thank you. Corey.
I'll second that. I'll also add that I think participatory approaches are really important for building trust and acceptance. And I think beyond thinking about just artificial intelligence and machine learning, we ought to think about ways of increasing representation in democratic governance, again, beyond sort of AI. So, yeah, thanks.
Thank you. Shamya, any last words?
Yeah, so I think of AI use as supporting heterogeneity than promoting homogeneity. AI really wants everyone to speak the same language, behave similarly, so it's easy for it to understand and predict and generate text and whatnot. But I am here to look for ways in which we can support human diversity, which means learning science in the language that is most accessible to you, as opposed to the English-only academic discourse that has been imposed on multilingual learners for several decades. So yeah, that's me.
Wonderful. Thank you. I'm incredibly grateful to our guest speakers today. I'm also want to thank the audience. Thanks for joining us today. I want to remind you that we will send out the recording probably later tomorrow. And I also want to reiterate the point that this is an event organized by the Institute for Diversity Science. It's a research institute promoting research on empirical questions related to diversity, equity, and inclusion. Please feel free to check out our website, ids.wisc.edu. We have plenty of activities going on. We have plenty of resources, plenty of information, and also descriptions of all the activities we're doing. Feel free to contact us if you have questions. And we always love being in touch with people from both the university, but also outside the university. Thank you so much, and have a wonderful day. Thank you. Bye.
Thank you.
Thanks.